Mueller, who is, are you still editor-in-chief? Oh, you're on mute.
I'm still until the end of the year.
Ah, excellent. So he's still editor-in-chief of our biggest and best journal. And I guess the structure of the meeting was that each of the participants would give us a 5-minute introduction to themselves and their interest in visualization and their thoughts on the future of visualization. And then we would open it to questions from the audience here. And please, those online people, don't feel shy about asking questions. We'll, if you put your hands up, we'll come to you as well. But there'll be 15, 20 minutes of introductions first. OK, Klaus, would you like to go first? Are you here?
Yeah, so I have to find the right one. OK, I got it. So now I have to see how to share the screen.
Oh, you want slides? If there's a share screen thing.
Open share tray, is that what it is?
It should
no,
be.
That's not it. That can't be it.
It's a little square with an up arrow on it.
Yeah, I don't. It close share tray. OK. There's a share tray, but then that means I can share something to you, right? Yeah. But I can't share my screen.
Oh, really?
When I say open share tray, then that means there's a file browser or desktop. OK, good. Oh, I thought it's like it's a very different language. OK, so here's my slides. Can you see them?
Perfectly, yes.
OK, so this is just I prepared this and my views on the research trends. That's my 5 piece. By the way, first my condolences to the loss of your queen and long live King Charles. So so here basically TVCG. I want to just give you some insight on TVCG, right? What it really is by the numbers. I call it TVCG by the numbers. So we have 1995 was funded and 7 EICs, editor-in-chief so far. Then there are 3 areas. Got to be aware of the VR, viz, visualization, and computer graphics. Then we have 72 AEs, which serve these 3 areas. Then we have so far 4,700 papers published over the years and 1,000 papers this year or last year alone. Then 5,000 pages and 15 partner conferences. The impact factor is 5.226. I'll go a little more in detail on this now. Next, so how do I write for TVCG? The scope is basically computer graphics, information, scientific, visualization, and visual analytics, and virtual and augmented reality. So this is the kind of stuff we published. And here's a bigger thing on it. So I'm not going to read that to you now. So impact factor, basically we are a little bit less than ACM talk, but we're in the same sort of class. And the other journals are here, which are below 3, the Clarivate index factor, like the other journals are here. So we're really the top journal in definitely the visualization field. And so, since it's UK, right, I wanted to I dug into the database and figured out how many papers actually submitted by the UK, just the UK, not the Commonwealth, to TVCG. So overall, we had 635 within the past 12 months, and there were 14 UK papers. And notice this doesn't include the special issues like visualization conference, VR conference, and ISMAR conference. So the participation might be higher. I didn't go and count them because I don't have the numbers handily. So when you look for emerging trends, so I thought about how can you identify this? So I thought, you can basically just look at the workshops at the visualization conference, right? So the workshops tend to be on themes that are emerging, right? So you want to look at these workshops and see what they're about. Then you get some guidance on what might be the hot areas in the visualization field. Then you can frame proposals based on that, right? So biomedical AI is definitely one. Then NLVIS, the introduct, using natural language, either for helping visualization to provide a different interface visualization, or visualizing natural language corpuses and things like this. So this is really a big issue, right? Bringing natural language into a visualization interface. And this workshop is about this. So this for climate, of course, climate is a big thing, right? So if you can help climate science and make the climate better, there is it's mostly a communication issue, right? So this is also a pretty good area. Tracks is the workshop on trust and expertise and visualization. It's basically, there's a lot of hoaxes conveyed with visualizations. So this is a workshop about making this more reliable and more trustable, these visualizations, try to keep it leveled on and make it believable, right? So this workshop is about that. Social good, of course, this is also a big topic, probably in Europe just as much as in the US. And this XAI is the workshop on visualization for AI explainability. So with all these trends of deep learning and machine learning and so on, right? This is basically visualization's chance to play a role in this, like to help AI, explain itself better and make it more trustable, which kind of goes with this tracks workshop. This is a workshop from 2021. Then another one is this machine learning from user interaction, right? You can learn from the user as he interacts with the visualization. You can learn intent, you can learn beliefs, you can learn all kinds of things, interests, and so on from users just by looking what they're interacting with, like what kinds of in the visualization, what kinds of areas are more interesting to the user. Then you can sort of find out what the user thinking about. So this is also a pretty hot area. Then the visualization, visual analytics in healthcare is something that's been around for quite some time. I listed it anyway because I thought this is still a very active field, right? Healthcare is a big thing, in Europe just as much as in the US, and there's a lot of AI in this, and you want to support the human, amplify humans' capabilities. So this is basically the workshops that I thought. Of course, there's more workshops, but I thought these are sort of trend-setting workshops. My 5 pence, okay. Then I also look at the names of paper sessions in the Visualization Conference 2022 and also 2021. Then you'll learn things like decision making and reasoning is a session this year. And another one is VA and ML, Visual Analytics and Machine Learning. There's another one, VA for ML, okay, and yet another one, ML for Viz. So you see, ML is there everywhere. Machine learning is there everywhere. When you look at these papers, especially the ones we get for graphics, which are abundance of papers, all of them, mostly all of them, try to somehow get deep learning into the picture and make things easier with learning, deep learning. I try to basically regurgitate all these mathematical concepts that existed and make them now a learning-based concept where you learn these equations instead of actually executing them, right? And there's a big trend. And then explaining them is like the opportunity for visualization, right? Oftentimes this stuff is, who knows, it might be dubious, right? What the machine decides. Then another one, visual analytics, decision support, machine learning. That's just another session title, understanding modeling how people respond to visualization. That goes back to the ML Louis workshop. Questioning data and data bias. Bias is a really big thing. Selection bias, fairness, and bias in the data, bias in the user. These are really big topics, right? This is something that is really coming up, right? There's also a lot of news on this, right? Immersive analytics and situated visualization. This is like addressing the VR and AR trends nowadays that happen in the metaverse, so on. So this immersive becoming a big trend, like because of the metaverse that is emerging. Uncertainty always been a big trend since, like, I think since I started research. Uncertainty visualization was always a big trend because it's just hard to communicate uncertainty. Dealing with scale, space, and dimension. This is kind of high dimensional visualization, right? And as the data collection goes bigger, there's more and more attributes that are collected. Also for, to deal with scale, space, and dimension is also about making these deep learning, these neural networks more efficient, right? Compressing them down by figuring out what the dimensions really are that are useful. Personal visualization, nowadays visualization is ubiquitous, so, there's also lots of personal data that people want to look at. And so on with visualization, interactive dimensionality, high dimensional data, also a very hot topic for a long time. Interpreting machine learning, that goes into this section up here. There's the three machine learning rubrics. Sports viz, it seems to be a trend that keeps coming up, like visualization for sports. There's a few research groups that do pretty well in this, but it's really, people are into sports, and there's a lot of interesting things to visualize and strategic and so on to visualize storytelling visualization. That's also, I mean, nowadays, as everyone can look at visualizations and sees them, and everything is computerized, and everyone has a social network and has these apps. You know, it's an opportunity to tell stories with pictures, right? Because there is so much bandwidth now to communicate these pictures, and so much storage for that, right? Text, language, and image data. Again, I talked about this before. You know, text, to integrate text and visualization and is also a big thing. Goes also with the storytelling, natural language interaction. So I put this into this word cloud to, you know, to really summarize all this, right? ML is a big thing, decision is a big thing, like bring the human into the loop. Learning is a big thing, machine learning. Analytics is, of course, always there. Language is there, natural language, data, of course. You know, this is are the buzzwords that I extracted through this word cloud from these terms. So anyway, I ended with the logo for my journal. I'm actually, my research is mostly nowadays in explainable AI, and has always been in visual analytics, done a lot of volume rendering in the past, but nowadays it's more like in explainable AI and machine learning. Okay, so that's my 5 cents. Pence, I'm sorry, pence.
Wow, that's a lot of cents in 5 cents. Yeah, thank you. Okay, we'll go through the other people and we'll open it up to questions and thoughts from everyone else. I'm going to give you a microphone at the front. Go first?
Yeah.
But there's also a microphone behind you as well, if you talk loudly on the desk.
Okay. Is this good?
Yeah.
Yeah, I'll use this. Hello, everyone. I'm Cagatay Turkay. I'm a professor at University of Warwick in visual data science and visualization. My research is broadly in the space of visual analytics, looking at how interactive methods could be facilitated, could be sort of integrated in data science processes and reasoning processes, and then recently more on also how complex models of sort of data products and how the data itself could be communicated both to experts, but more broadly to sort of wider audiences, as we had a brief discussion at the end of Min's talk. Just looking at today's brief and then looking at the title, like priorities for AI and data science, for research in the UK primarily. So I've sort of tried to think about that in maybe 2 separate headings. The first sort of set of points I want to make are about the more specific challenges around data science and AI. And the second set is maybe more generally about like visualization, a few things to think about. And these would be my, I guess, 5 cents. More specifically in the space of data science and AI and the role of visualization in that space, one challenging topic that I see coming back and becoming ever more pressing is that balancing of human and AI effort, and balancing human effort and computational effort in reasoning, in working with algorithms, in working with data products. So we need tools to sort of give space to express, space for people to express their tacit knowledge, their experience about the context that they're interested in, while giving the AI and the algorithms the maximum benefit to the problem that they are trying to solve. There have been lots of issues where these balances is not really kept, like when AI, like where algorithms and automated methods are suggesting suggestions as sort of like, or making decisions on our behalf, and that balance is not really catered for, then there's a resentment on the human side that they're being overruled by those algorithms. Whereas if we manage to sort of understand a balanced way of working between the humans and the algorithms, that would be a much more successful process. And the visualization has a particularly key role in that space, partially due to our sort of years of experience working with people and data in that space. So we've learned a lot about how people reason with data. We learned a lot about how people interact with algorithms, especially in the visual analytics research. And I think we have a role there to transfer our learnings and transfer experience to the space of AI, and then the new challenges and new models and new techniques that it is throwing at us. A little bit on building on Klaus's point, the second big challenge is around understandability and actionability, explainability, how you name it. The challenge is there, it's the same. And then maybe part of that balancing and human AI strengths is that how to communicate the decision logic and the reasoning logic of algorithms to people in ways that are understandable and maybe most importantly actionable, so they can really benefit from it in their own work. And this comes through maybe communicating uncertainties, communicating variations, and maybe giving interactive input, interactive mechanisms for people to understand how these different models work. The final role I see more specifically in the space of data science AI for visualization is more on facilitating and establishing a more critical, more reflective, a more engaged data science practice in general. It's about building a generation of data scientists who are much more critical about the tools they are using, are much more critical about the data that they are working with. So they are aware of the sort of pitfalls. They're aware of the sort of issues with the data. They're aware of the biases in the data, but also their own biases. So they reflect that in the data science process. And I think visualization has a key role there to both surface those problems and surface those issues, and give the analyst the space to ask those right questions at the right places in the analysis process. And then I thought these are sort of maybe like specific to the data science and AI, taking a bit step back, and then what do we need to do in terms of what do we need to think about in terms of visualization research? The first thing I was thinking, we need to get visualization research where it matters the most. We need to sort of make sure that the tools and the solutions and the techniques that we are seeing today in MinStalk in front of people who are using, who need those tools. And most often than not, those tools end up just being in these laboratories and they never make out of those papers. We need to make sure that there are informs that could be embedded in workflows, they could be used by those who need it the most. But it's not only the tools, but also the guidelines and best practice learnings. They need to be also out there helping those who work with data, who work with visualizations regularly in their day job. The other one, I think there was a lot of it in MinStalk as well, like the theoretical foundations. We need to establish that much more sort of strongly. There's of course more and more growing interest in linking up with other disciplines. I mean, there's psychology and vision research has been quite influential recently, but we also need to recognize that the visualization as used in the wild has also quite distinct challenges. They might not be immediately observed in a laboratory. So we need to make sure that we are open to new methodologies, interdisciplinary methodologies. We might want to sort of just not look at how visualizations are understood, but how they're understood in these different contexts that people are using that. And that would require us to engage with methodologies from social sciences and humanities, not maybe just the sciences. And finally, the point I will make is, and that was also in Klaus's list several times, we as a research community, we need to engage with societal challenges. We need to be at the forefront of these big challenges. There are lots of problems that are coming at us, like climate change, inequality, poverty, energy crisis, and all of these bring unique visualization challenges as well. I was on a workshop on Monday where the question was, and it was with police forces, how data could be presented in courtrooms to the jury. Like how complex data products, how complex algorithms could be explained to a jury so that they make a fair decision. There's a sort of like a pressing challenge for you, and then these kinds of challenges are popping up everywhere. So as a community, we need to make sure that we're at the forefront of those challenges and and directing our research interests in those areas where we can have real world impact. I'll pass on to you then.
Thank you very much. Thank you. Okay, hi. So my name is Maria-Cruz Villa-Uriol, and I am lecturer in the Department of Computer Science at the University of Sheffield. So I'll tell you a little bit more about my research. I work on visualization, but I come from modeling, modeling diseases. So I'm interested in looking at temporal event data, what is happening over that time, how to cluster large amounts of sequences. The applications where I've been working are on the analysis, for example, of calls to emergency services and how first responders react and bring patients to the to emergency services, and trying to detect bottlenecks, looking at how outpatient services at hospitals behave, and trying to again identify bottlenecks. Now we are trying to look at evolution of chronic diseases in the aging population. So we are collaborating with an Institute of Healthy Aging, also in Sheffield. And I want to bring in also the fact that why I am here. One of the reasons is because there's a Turing Network Development Award awarded to Sheffield, and there have been a number of community meetings where researchers in AI and data science are working at the university and trying to build new community links. And among the many interest groups, there's one on visualization, and I am the leader of that interest group. And it's been surprising for me how many people at our university is using visualization, and the amount of interest. There are lots of people in the sociology, astronomy, engineering in general, who have an interest in urban planning, urban studies, that are interested in using visualization. So I think that from that point of view, that perspective, there's a great opportunity to link to all these people and to all these researchers. Now, in terms of the challenges that I think there are in this area, in visualization, of course, I fall in the same category as you in terms of visual analytics. That's where my work is. And I see that, and I'm using applied machine learning. One of the things that often surprises me when I look at people working in machine learning is that I got an algorithm, I get a result. For example, let's say a clustering algorithm, I get some results according to a metric. That's my solution. And I'm coming from the side of trying to understand what is that solution. And I'm like, no, but this solution doesn't make sense. But according to this metric, that's the best one, okay? Or certain numbers. So we are looking into how to make more informed decisions about the different solutions that you might be having by running different machine learning algorithms. Sometimes the amount of data that you have is insufficient, and that's why you need to bring in some expert knowledge as well, and domain knowledge, trying to understand what are those. And I think the visualization, trying to understand those solutions, can bring in a lot into making better decisions and support decision making, if you like. So that's links into the machine learning explainability, interpretability of results, and supporting even machine learners because sometimes they don't look at the data into that way and into their solutions in that way. What else? Well, in healthcare, I work a lot in healthcare, and in healthcare there are lots of opportunities, but there are lots of challenges. And one of the challenges is accessing data. And I think that this might be a common theme to other domains. But in healthcare, some of the data is very delicate and very sensitive. So then you need to be very careful, and it takes years to access those data sets. There is lots of heterogeneity. I think how to integrate all these different data sources. I think that, again, visualization can bring in lots of good things in this area. What else? So that's on the side of the I would say the data, the models, and what visualization can be doing in terms of machine learning and interpretability and explainability. And then the last thing is on evaluating. Whatever we are doing, it's very difficult to evaluate and have a valid, a good evaluation. You know, we were having some conversation earlier before entering, you know, while the coffee, during the coffee break. And well, it is always the same. There's going to be so easy to criticize whatever evaluation you design, because by definition, you cannot have access to the amount of people that you would require, the variety of backgrounds. So there needs to be, I think, a serious reconsideration. I don't know even if it is possible, but I would welcome more work in this area about how to perform more solid evaluations so that we can compare to each other. Trying not to be very naive or obvious. I think going into open science and trying to disseminate whatever we do much better in terms of tools. I know that there is a lot in this community going into that direction, and I think this is great, but I think we need to keep going in that. And also there is another research challenge, and it's how we can communicate better what we do. And sometimes, so that researchers, for example, in astronomy, it's much easier for them to identify what we do as something that can bring them value. I liked what Ming indicated earlier. He was saying, well, sometimes it might be a problem of funding. You know, there is not enough funding, and projects, you know, yeah, that would be fantastic to have that, but there is the amount of money that there is, and we cannot bring in everything that we wanted. But I think if we upscale and examples like Granby's and all the good things for visualization that COVID has brought, I think that we can have a better presentation letter in order to have more people on board. And I think that I will leave this here. Thank you very much.
Thank you very much. Sorry. So my name is Alma Cantu. I'm a lecturer at Newcastle University. Sorry. My research primarily are around how to explore heterogeneous and complex data by relying on user perceptive biases. So I'm going to quickly go back to my former project before introducing different challenges that I've seen. So I will start with my PhD because I'm quite a recent researcher. So the idea of my PhD was to investigate the advantages of virtual reality. At that time, there was not even mention of immersive analytics. But so the question was, how can virtual reality can help exploring signal intelligence data? So signal intelligence is basically exploration of signal radar by military operator. And we built some tool basically around displaying raw data and playing with user perception, Gestalt theory and colors to be able to provide these operators the opportunity to explore data. So a lot around perception. Then I've done a postdoc position in human factors, so left civilization for a bit, but it was still some component we were trying to evaluate the advantages of shape-changing surfaces on aeroplane cockpits. So basically, we wanted to nowadays we want to have touchscreen in cockpits, but because of turbulences, you cannot have touchscreen. So we were trying to evaluate how shape-changing surfaces will help you to interact with cockpits, and I was very interested in the perception aspect again. What will change between like virtual shapes and actually physical shapes in cockpits? And then I came back to visualization on a postdoc at Newcastle University, where we were trying to to explore some mobility data, because nowadays there is a lot of disease that will actually affect your mobility, like multiple sclerosis, Parkinson. So it was a massive project with people from Sheffield actually. Anyway, where we were trying to, so I will lose track of what I was saying. Yeah, we were trying to monitor health states through the people's mobilities. So again, a lot of discussion with biomechanics people, and also we decided to explore how to bring all this data and all the information to the patient. So it's quite a nice link with different challenges. I think will be interesting to tackle, because well, we discovered, not really discovered, because something everyone kind of know, that there is a gap in the understanding of data with older people, aged people. Realize that society puts them apart because they're not able to explore data as maybe younger people will do. So I think one of the main challenges will be to consider users and to, well, it's have been said already, but to bring back this link and all like older people, but everyone else, to get access to the data and to be able to explore, because visualization is about data acquisition. So just bring back this link between humans and their own data. I'm also very interested, I think what's also interesting is to go back to this question about user perception and how biases in user perception can help you acquiring data. For example, also this question about Gestalt theory. So you must all know like the different perception theories, but I feel like even though there is already a lot of work on how you can apply them to visualization, there is still, I feel there is still some area to explore, like well, when I say perception, I'm also including like perception, acquisition, acknowledgement. So all the data acquisition loop, I may say in the loop, like process, if I may. I think there is a human in this process will be biased in a many different way. And I think if we understand better how the human perception biases, we might improve how we the data acquisition process. So for example, I was saying Gestalt theory. There is also everything about ecological perception. So the fact that you might interpret the data better if it is presented in an ecological way. So there is a lot of work on this, but some people will be like, it's not something you can come up with, it's something you discover. So I would be very interesting to be able to explore this further and to really use them for data visualization, and also like all the other perceptive bias we know, like it's not perceptive bias, but perceptive aspect, like if I go back to virtual reality, like motion parallax and stereoscopy, all of this different visualization process that I think are very interesting to explore a bit further to understand how they can affect data acquisition. And finally, sorry, so it might seem like you go in a lot of direction, but it's all about the perception and how user want to go back to the data. I will join everyone about all this question about, if I may, explainable IA. My point of view is, so I'm now in a data science department. So I have colleagues who do machine learning, IA, image processing, and I believe that we work together when we create, we all of us bring data to users. So we can work next to each other. So they provide the algorithm, we provide visualization, but we can, as vision experts, we can provide tools to understand what they're doing, as well as they can provide tools to help us with visualization. So there is a machine learning that's going to generate visualization. So part of this interconnection will be us to provide visualization to understand what's happening in machine learning, what's the different process, but also and help us visualize the outcome of this so different processes. Well, I hope I was clear, and if you have any question for any of us, I guess we'll let Nick just.
Cool, thank you all. Thank you very much. A wide range of thoughts there. Alyssa? No. You've travelled a long way here, and you're really an astronomer, and yet, because the visualization community has not built the tools you need, you've formed your own company.
Yes.
Was that out of frustration about our community, or was it because you had boundless new ideas?
Oh, let's go with boundless new ideas. There is some frustration. I mean, it's funny that you ask this question, because when I go to the Viz meetings, which is very, very rarely, I know a lot of people, and the people I know are the people who run the big companies and who are the heads of panels and this is because they like that there's some weird astronomer who cares about visualization and they follow what I do even though I don't really write papers in visualization. And so that to me is kind of a demonstration that if people in the domains can get that much visibility in the visualization community, there's actually something wrong, okay? So in other words, I think it's rare that somebody who's in one of these domains is that interested in visualization so that, you know, I can have an almost intelligent conversation with people who are really visualization researchers. And so I think there's still a really big gap. That's why I asked Min the question that I did. And, you know, if some random physicist heard about, you know, oh, well, VAST versus SciViz versus InfoViz, they'd just be like, what is this navel-gazing nonsense? And you know, the software, so what Nick is talking about is that we have the software called Clue that was funded originally by the James Webb Space Telescope and is the software for the James Webb Space Telescope, but now is the software for many other things, including through this private company we spun off from it, Genomics Research. And the point of that software is actually to integrate not only data sets, which some of you are talking about, but also InfoViz, SciViz, and VAST in one, you know, what you call it, product, okay? And so like the idea that I would have to choose which session to be in at one of these conferences really does bother me. And so I think there's a kind of unreality to the way that Viz research gets divided up into these little bins. And so I was totally serious when I said to Min that, you know, recombining these things and things like having a real journal that you guys now have, thank you very much, is great. And so I just think it's a relatively young field and it came from kind of a strange place where it decided it had to be really serious right away. And I don't mean to, I mean, some of my best friends are visualization researchers and I don't mean to insult anybody, but I think taking it a little bit more like engineering and a little bit less like theoretical science would help the world and really kind of communicating what it is that people do. And I'll just say one more thing because I'm saying too much, but at lunch we were talking about, in the US anyway, there's a lot of drain on people who are really talented into industry. And then the stuff that they do there is largely not open, but is often better than what you see in any academic lab. And so there's also something wrong with that. So there has to be some kind of better interplay, I think, between companies and academia, and to some extent open software is something for that. And of course money, but I'll stop there.
Thank you, that was really interesting. Klaus, you have any thoughts about?
Well, number one, the Viz conference has now joined, like it's reunited, right? There's no more SciViz or VAST or InfoViz, it's all Viz.
Right,
Yeah, visualization, visual analytics. So, you know, this is just like I think this is the second conference where we have that. So we no longer distinguish, and the tracks are really intermixed. We have now 6 areas, like rendering is one, and decision is another one, and theory is another one. So it's like more like Kai or like you know, computer vision conferences, things like this, where it's more area, and then we have area chairs that go with it. Then secondly, what you say about the brain drain to the industry. Yes, I mean, I actually have also a startup company that tries to do this, right? A very, very small company. There is a big gap between you know, that there's a fertilization that goes on in the research lab, right? And there's user studies and so on. So many things never make it out to the real world. But that is very, very much needed. You need academia to drive the products, right? Usually the products are like an amalgam of different research products together. Like in my company, for example, I mean, we have taken, actually, the company was founded on a research project I had, like a research that was NSF funded even, but it just didn't work quite like that in the real world for real data. And people actually didn't really, it worked great in user studies that we ran with academics mostly, but then on Mechanical Turk. But then when we showed it to real people, like in the financial world and in other domains, they just looked at it and the eyes glared up, right? They didn't know what it really meant. So we then changed it very differently and still have changed it more, you know, where, you know, it's what, you know, but you need this. You need what I feel I need this research knowledge that I have to make a good product, right? That works, because there's a lot of things going on underneath this where it's actually not visible to the user, but it builds on it, right? So you need these research papers. You do need them. You need oftentimes the things don't matter in the real world in the end, but it's kind of like fertilizer, right? It's like in the ground. You don't really see it, right? But the flowers is the only thing you see, or the wheat, right? But you don't. The fertilizer is very much needed. So that's what I'm thinking about.
Alyssa wants to say something.
Hey, Klaus, I just want to apologize. After the talk before the break, Min was talking about the unification of all of those pieces of biz, and I'm aware of that, and I'm very happy about that. And as to your flower analogy right now, I agree that you totally need the fertilizer, and all I'm saying is that more people need to see and appreciate the flowers, even the ones that do bloom, and I think everybody was saying that on the panel.
Yeah, I think it's coming. I mean, a lot more flowers are visible, right? The storytelling with visualization, D3 has made happen a lot, right? Because now everything is more visually appealing and more eye candy. That makes people get drawn to it. We understand a lot more about humans. We understand a lot about memorability, but that it really helps users. And then when you look at Facebook, right? I mean, if you have a post without an image, no one reads it, right? You have to have some sort of image. And sometimes it's not needed, but to understand what's written. But it's a good guidance, So we've been working on caption generation from images, right? To make images and then derive captions from the image, right? So we've been working on this, and we actually have a paper at the NLVIS conference, this workshop this year, how to use GPT-3 to generate good captions. So now it comes a prompt engineering, right? That all these sort of trends you have to pick up on and integrate them into your own research, right? They can be your friends, right? Never do this in a vacuum, right? Embrace everything. Read computer vision papers, read natural language papers, pick up on the trends, and then make them your friend.
Cool, good advice. Okay, so questions. Anyone in the audience, online or in the room? Rita.
I have a question. This thing comes up a lot, the difference between the results from industry to what we can produce in academia. And there is an issue which is sometimes you have perceived as developers by especially external companies, and we are not developers. So we can only bring the research up to a certain stage. And also we can't ensure that our students obtain a PhD by, for example, developing something which looks extremely good. It has to have some advancement for state of the art, so it's a challenge in that respect. And yet we generate these highly skilled researchers then are absorbed by the company leverage them, then come back to us and say, oh, why are you doing enough? And that really is something that I've heard from some of even the companies that came to recruit the Kings. So my question is, how can we, is there a way where we can still maintain the science and bridge the gap that is kind of keeping us a bit distant from more the application domain? So one thing we've been looking at in Kings is this video of research software engineers. So someone can help them experience in this area, and one of the panelists, or there are better strategies to make the point.
Well, my experience with that is, yes, research software engineers definitely help put things in the real world, and we've used them to take research ideas and put them into working tools in some sense. I don't know if our head of one of our research software engineering groups wants to say anything. But
thank you, Rita, for mentioning that. It was one of the things I asked in a way, although it was sideways to the first keynote. It was about this quite large umbrella term that now the research councils in the UK use, which is called research technology professional. And within that, we could also include research software engineers. And I think within that, we be quite inclusive and make sure that the kind of expertise that you are describing here, which is really related to visualization, design, UI, UX, and all the areas that are fragmented within these community, really that expertise professionalized, and I think not necessarily exclusive to a PhD track, but complementary or additional to a PhD track, so that we do have that expertise integrated within research teams. And as Nick knows, there is a big international and also now national community that is looking at professionalizing research software engineers, both in terms of role, but also careers. So within Digital Lab, which is the team I lead in the Faculty of Arts and Humanities, we have different roles. Some are related more to analysis and requirement elicitation, so to bridge exactly that element of research and design and development. Some are more focused on implementation, development itself, some are on infrastructure and systems, and then some on design. And we keep complaining that within a team of 13 people, we only have 2 UI/UX designers. We'd like that to be bigger, but the reason why we don't have that is because we have not a lot of funding for projects that are really focused in these areas. So it'd be great to see more of that and to see more integration and also to work towards developing those career pipelines within our curricula, whether they are in NMS or information sciences or digital humanities or other areas. So yeah, thanks for that. Just thank you for the time.
So one of the things that the Turing has is convening power and policy influencing power. So we could start to think about how we could use that to encourage more investment in this area. I know the Turing in particular are very keen on collaborating with visualization research software engineers. So we might find that's an open door to push into, and they have access to some industrial impact funding that we don't normally see. So that could be a route forward. Yeah, and I would echo what Klaus said. I went the wrong way around, I guess. I went from industry to academia, but the products we built on science, we had to completely change the science to get the products to work. It wasn't anything like what we thought at the beginning of time. Any more questions in the room? Oliver, you're online now. Do you have a question for the panel? If you're feeling well enough. No. It's probably looking for the unmute button. Oh, he's grayed out. He can't join. Oh, sorry, Oliver. You'll have to join as through the app to be able to talk to us. Or he could try and write it in the chat. Yeah. Any more thoughts in the room? Yeah.
But the point that you raised about sort of context visualization being driven by the context of the discussion. So I'm an assistant professor in computer science, and I've been in this community since I was doing my PhD years, but then I sort of shifted or drifted away a little bit and have been very much immersed in a place called the Center, the Wilson Center for Applied Health Research. So working in very close collaboration with epidemiologists, public health, population health management experts. And there's so much interest in visualization, and there's also so much linkage of data sets. So in Bradford, for example, we have the connected Bradford data set, which links up data for 800,000 citizens, including healthcare, education, policing data, housing, lots of different things. And they're really sort of seeing how this data can inform different decision-making contexts. That takes us back to this idea of contextualizing our task analysis and our requirements analysis. And I'm seeing lots of challenges in really finding in the big literature, guidelines or some sort of theories that can guide this process and really tell us a little bit about how these contexts can be defined and whether we can systematically map the sort of contact points within those contexts. So in the healthcare domain, they're always talking about systems approach to quality improvement, improving sort of different services, using data sharing, and obviously visualization is a huge. So I remember when I first joined the WOPS, and I got an email from the director of research there with the subject line, help. We saw some of the D3 visualizations that I had created for a previous project, and D3 is actually one of those really attracting us. Obviously, the idea of sort of aesthetics again and creating beautiful visualizations is a real strength that really captures people's attention, and it's amazing. It was amazing to me to see that people who have so much data and so much funding, they've never seen anything like D3 before, and they were saying, well, I've never seen something like this before. So I think there's a lot that can be done in terms of bridging the gap between what we do in this community and what these people are looking for on the ground. But there's also
a need for this mapping to be more systematic in a way. We've touched upon it in a VIS 2020 paper. We're working on a project called Dash, where we tried to sort of elicit some requirements from different hospitals. So we were trying to develop a dashboard generation for 5 hospitals. So we kind of managed to do a little bit of systematic mapping for the requirements, but that was just for this particular context. But expanding this beyond that, looking at more diversity of stakeholders and looking at how we can map this space of tasks that they will plan to take, just given one data set, which is a huge data set, but still just one data set, but we're still struggling very hard with that. So any thoughts on that would be really
Before there's any thoughts, Klaus, are you okay to stay any longer? I know that you had other meetings in the background.
I can stay a little longer.
Oh, brilliant. Excellent. Good. Ollie, you're here.
Yes, I've made it. So sorry I couldn't be with you in London today. I did have a question, and it was tying into something Lauren said yesterday. I'd like to put this to the panel. What if data visualization isn't about the most efficient understanding of data, the fastest way of understanding it? What if it was about making us stop and think and engage deeply with the data instead? What about this idea of slow science, where we take a long time to understand a data set? Does that fit into your framework for the understanding of the future of data visualization?
Alma.
Well, sorry, sorry. I was actually a bit confused because I was thinking about answering the question of the first question. It was someone asked a question just before you asked yours, so I'm in between 2 questions. I'm not even able to remember which one I want to answer. So if sorry,
Confuse you so much.
Okay, so okay, now you confused me. But no, you were saying about
slow visualization.
Yeah, exactly. Slow versus quick. I think it's very good. My approach is a slow first, exploratory, understanding, because I think that we are rushed. We want rush decisions. Okay. I see that trend. You know, we want quick, 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 quick. Our life is like this. Our society is like that. And it is demanding this quick, quick, quick. But I don't think that's, you know, every time I look at that, it's like, no, slow down. What is it? You know, before doing anything, what is it? And that's, I think, where personally I position myself. I think that then there are users like emergency responders or things like that they need quick, quick, quick. But you know, and for those you need to develop, you know, quick and fast solutions. But first understanding, and then with that understanding you can develop and target what these quick decisions need. That's my approach, but I don't know.
I was going to respond to the other question,
Go for it.
but I'll come back to you, Ollie, in a way. I think it's excellent point about the contextual nature of visualizations and how situated they are and how those interactions happen in these settings, and they're very different to one another. And you're absolutely right that the literature is quite mixed in how transferable findings you can get from one paper that looked into a particular context. I mean, design study methodology has sort of emerged as one sort of quite commonly used technique in visualization now. It has been like one of those paper categories and types where you dive into a context, do some requirement analysis, try to understand like who are the stakeholders, what the data needs are, what the data is, etc. Sort of what are priorities, etc. And I think that design study methodology has done a lot to at least standardize a bit of that methodological process. But I think as the field is growing, as we deal with more and more different problems, that is also, I think we're like outfitting it. I mean, it's that we need methods like different methodologies, ethnographic methodologies. We need different method like the participatory methodologies, co-design methodologies. I think the methodological need is also growing. In terms of standardizing standardizing the outputs. I'm not sure we're there yet, but there has been calls for that. There was a paper from Jason Dykes and Maria a couple of years back, I think 2 years ago, on how to report design study methodologies in rigorous and sort of informative ways. They come up with almost like a guideline of how to report a design study as effectively as possible, so that you're able to sort of transfer it or translate it to other contexts. I think that will be, hopefully, that could be one signal that there's drive to be a bit more systematic about those mappings of between problems and what kind of problem it is, what kind of approaches are more effective in that. But yes, definitely it's something that's one of those challenges that we need to think about and try to sort of come up with guidelines that operate well in different contexts, and sort of try to publish them in ways that are not just maybe hidden in some subsections in the papers, but in ways that are sort of like actionable, that people can take it and apply it when they have a problem in healthcare or in astronomy or whatever that context they're diving into. So yeah, it's excellent question, but yeah, I think it's quite fragmented how we are dealing with it now at the moment. And on that second question about fast and slow, yeah, I think it's an excellent point. Partially when I was saying that visualization could be a facilitator for a critical, reflective, and slow, like informed processes. When you were making that point about how you make informed decisions, it's all of those qualities are about being slow rather than being fast and like jumping to conclusions. And in a way, visualization, yes, we've always been thinking about this attentive processes and that things should jump out, and there should be like we are using those, maybe the fast processing power of our visual system. Actually, yeah, we are trying to use the slow and strong cognitive mechanisms of the sort of reasoning processes of our minds, and I think that's where visualization's real benefit would come especially in this context of data science and AI, where we work with complex data and complex problems. Yeah, I think so. Yeah, I agree in that.
Okay. I like what you're saying. When I'm saying slow, I like the fast aspect that visualization gives you, because that interactivity, that's what I think, for me, that's what I love. Okay. And I think that most of us, I'm sure that we all love that. Right? That quick way of exploring the data, but slow thinking about too. Yeah. So yeah, totally. I cannot agree more than with you. Yeah. And about what you were mentioning, I think that whenever you face and you are with these huge data sets, and if you need the stakeholders, and you need to develop all that with them, because for one of the papers that we will publish, we don't need such level of detail. And for example, when I show the sort of stuff that I do, sometimes when I talk to the stakeholders, they say, okay, what has happened with that? And I say, well, we published a paper. Okay, congratulations. Okay, but is anyone else using that? That's, I think, the one step next, and I guess that we've touched up on that. Yeah.
Yeah, I can also say something to this, Oliver. This is very interesting what you say about the quick and so on. So I actually worked with a government agency once, and we eventually designed a visualization solution with like some mid-level people, and then we finally ended up at the senior guy, and he looked at it and said, visualization, it should just give you the answer. I want to do anything. So what is it about this visualization? What I have to work on it? I have to actually explore, what is it, right? Although our solution, I think it was a lot better. I mean, right now, what they did was basically work with spreadsheets and switch columns around, right? We gave them a lot better, but he thought we could do so much better, just that automatically the insight would come, right? You make a picture and it comes out, right? You don't have to work at all, but that's not what it is, right? So, but the quick, is kind of like, you know, if a visualization doesn't feel like an iPhone, right? Nowadays, people always, everything is so intuitive on an iPhone, right? You don't have to read ever, although there are some things you have to read the manual about, but most things are very simple, right? And it's intuitive. And so Steve Jobs also, when you look at remote controls, I have the Samsung TV. The remote control is terrible. Then I use my set-top box from the Apple what is it? The movies set-top box, right? It's like that interface has just 3 buttons, but it's simple, and I can figure out everything. It's just hierarchical. The organization is quite nicely. So if visualizations work like this, you could probably get these people involved that are thinking about quick, because they could just like do something, right? And then immediately it falls out. They have to do a little more work, but that is probably the key. And that is done with user studies, right? But with not just with your friends from the graduate lab. You have to go out a little further, right, to the real world. Amazon Mechanical Turk is one way to do it, but then you don't really collect what people think about it. But you're right. I mean, I had the same problem with this. And then about Anna, I think was the name, the person in the audience who said about the different domains. Yeah, I mean, that is true, right? The domain language terminology is really a big problem, right? And financial industry uses candlestick charts, and then if something doesn't look like a candlestick chart, they don't know what it means. Statisticians use biplots a lot. Then when you show biplots to other people, they don't know, what is this? So there's a lot of entrenched kind of, people just getting used to something, and they go down this sort of family of visualizations methods that they don't want to give another one a chance. Contextualization can also mean that, I think I heard that name. It was a little hard to understand. The contextualization probably also means like contextualizing your data set in the bigger frame of data, right? You may want to look at, So there was an interesting paper by I think Cashman wrote that was based on a DARPA project that created a knowledge graph on the attributes that might relate to the attributes in your data set right now, which you might include in the analysis, and so get a bigger picture and contextualize that information and embed it and couch it a little bit in the surrounding environment that it goes with. So I'm a big believer in this. Like data fusion is something I teach every time in my class, and I give extra points for students that do that. So there's a lot of knowledge you can get from data fusion. So we have a paper coming up on this actually maybe in a half a year or so.
And just back to the person at the, sorry, I don't know your name. Did you still have a comment?
Sorry. Yeah. So no, actually, this is brilliant and really answers my question. Just kind of a couple of comments. So on the idea of fast versus slow. So one of the quotes from our clinicians in a pediatric intensive care unit came to mind, which she said to me, "You want me to sit down in front of a computer to understand what the visualization is trying to tell me? That's not going to happen. I want to skim through, like as I walk past my screen and I see it, there's a problem." That's how fast she wanted that information. But again, that brings us back to this idea of context. This is a particular context that she wanted that quick information in. One of the things that I found recently very, very helpful is the CVO framework. So the Creative Visualization Opportunities framework from Maria-Cruz and some of her colleagues. We used it for 3 different co-design and participatory design workshops, and it helped in a way. But I think so just kind of saying that there's more that can be done in terms of, it provides a breadth of coverage. It allows us to sort of scan the space of what tasks look like and what contexts of decision making exist and so on. But just kind of digging deeper there I think is a gap in the literature around that. So,
thank you. Alma, do you have a?
Yeah, thank you. So yeah, sorry for before. I think what we can get use from is maybe the field of HEI. I don't know if I'm allowed to say this in this discussion, but I think you can learn a lot from them because they already have all this problematic. And it's a question around slow and fast, not a question about facilitator and learnability curves, because this has been studied extensively, and it's about where do we want our cursor in the learnability curves when we're presenting something. And I think it's, again, as everyone said, it's really dependent on context and user, but it's just to know where is this. And again, for what you were saying before, it was the word is not facilitator, but brings this link with industrial and guidelines to help go through. This is something that also maybe Asia is slightly better than us at it. So I think there's a lot to get from this field.
Excellent, thank you. I'm going to start to wrap up about now, so that we can still have coffee and biscuits and chat for a bit longer. Are there any burning last things anyone wants to say on the panel, or what should I take back to the Turing and say, this is what visualization in the UK should be? I'll have to read my pages of notes and find out for myself. It's something we'll certainly be doing. We'll be doing that in various contexts. I know there will be CDT bids going in for PhD students in the next few months. There'll be bids going into innovation. There's a very large amount of innovation funding in the UK to help businesses, and we're trying to influence that in the direction of visualization. And we're trying gently to push the Turing to take visualization more seriously as a theme across all their programs there. So that'll be the hope. And as I said earlier, we'll try and update our landscaping document for the Turing in visualization by the end of this year, so we can start to use it again as a policy influencing document. That's the goal. So with that, thank you very much, Klaus, for being here. I know you're so busy, but it was great, brilliant, and also for dialing in. Thank you, Tom.
It was very interesting. Thanks for inviting me.
Yeah.
Nice to see everybody.
Good. And if you think of any ideas for the UK, do tell us. All the way from New York. And thank you to everyone still who's here. Thank you to everyone who's online still. But and get in touch. If you want to join the visualization interest group at the Turing, anyone is welcome, from companies or not companies, academics, researchers. And we have fairly regular meetings once a month. And we now have quite a packed seminar series for the rest of this year coming up. Kai, who's not here, I think, is organising that really very efficiently this year. So with that, I'll close the meeting. Thank you all. Thank you very much.
Thank you.
Oh, no problem. Can you close the meeting, Klaus? Are we? Yeah.